So now you've had a chance to learn about the mechanisms of threads. Now that you've got the kind of an overview of how they work, let's talk about the class methods. And we won't talk about all the methods in thread, but we'll talk about a whole pile of them. The methods we're going to focus on are the ones that are the most commonly used in concurrent Java programs. One very interesting method is called setDaemon, and this makes the thread a daemon thread. Daemon thread's kind of a funny term. If a thread is marked as a daemon, then if the main thread returns, and of course the main thread is not something you typically start yourself. That's started for you by the runtime system, the execution environment. When the main method, which is a static method in Java programs, returns, when that returns, one of two things happens. If there are other threads that are non-daemon threads that are running, the program won't shut down. If the only threads that are left around are so-called threads marked as daemon threads, then the program will shut down. So daemon threads are used for threads that kind of run in the background and do sort of system-oriented tasks, but really are not essential for the proper ending of an application. And so if there's nothing left but daemon threads, then the process will shut down. The start method, that's the one that allocates the resources and initiates thread execution by calling the runHook method. The runHook method is where the user supplied code is provided. The join method is used to wait for another thread to finish. It can be used for barrier synchronization, simple form of barrier synchronization. You will use a loop in your assignment 1A to implement barrier synchronization where the waiter thread will wait for all the other being threads to finish doing their gazing. By the way, the thread that joins on another thread doesn't have to be the thread that started it. It could be some other thread, but it has to have access to a reference to that thread. Sleep is a method that will suspend the execution of the current thread for the given amount of time. You can find out some information about the current thread by calling the current thread method. That'll give back an object that describes the characteristics of that thread, which can be useful primarily for things like debugging and logging. Interrupt is a really interesting method. We'll talk a lot more about interrupt later in the course, and you'll get a chance to play around with that. It posts an interrupt request from one thread to another. And we'll talk a lot about this later as well. This is the common way that you tell another thread you'd like it to shut itself down, please. And it's always done in what's called voluntary fashion. So that's interrupt. Interrupt will interrupt the calling the current thread. I'm sorry, interrupt is a method you can call on another thread to tell it to interrupt. There's also another method called isInterrupted, and this will test to see whether a thread has been interrupted or not. So if you are the thread that's doing some computations in the background and someone interrupts you, you find out by calling isInterrupted to see if you've been interrupted. And we'll talk more about that later. One of the interesting characteristics about the isInterrupted method is that you can call it multiple times to check if you've been interrupted, and it won't affect something called the interrupted status. And that is in contrast to the interrupted method, which also checks to see if the current thread has been interrupted. And if it has been, it resets the status to uninterrupted. So this is kind of a one-shot thing. You can check to see if you've been interrupted, and it sets the status back. Whereas this thing checks if it's been interrupted, but doesn't change the status. So it could be called multiple times. For the time being, don't worry too much about the difference between these different methods. We will cover them in great detail later in the course when you need to have that information to use them in assignments. There's also a couple methods to set and get the priority of a thread. Priority is used to indicate what's more important, whether a thread is higher priority or lower priority. And in this model, higher priority is a higher value. In some priority schemes, lower values mean higher priority, which seems a little weird, but in Java threads, higher priority means a higher priority value means the thread is of higher priority. And all things being equal, higher priority threads should be given preference by the thread scheduler when it comes time to choose amongst multiple candidate threads that might get to run because they're waiting, they're runnable, but they're not running, the priority is used to organize which ones go earlier. So you can kind of think of the thread scheduler as keeping a priority queue and searching for the next highest priority thread when it comes time to run a thread. So that's the end of the overview of the key methods in the thread class.